Welcome back to another one of my vector components videos. This one will be focused, this is my second one, and it'll be focused on 3 dimensions. So let's just get right into it. So I explained components was when you have a component, it's part of something bigger. So if we have our vector A, that will equal, let's say 2i plus 3j plus 4k. That means this is the vector and these are the components. This is what makes up, when you add all these together, when you sum them together, it makes up A. Okay? Just like how a wheel is a component on a bicycle. Or, I can never think of a second one. But that's just it. It's just the part. So, these are the parts that make up this vector, essentially. So I'll draw that up. Hopefully I don't need a ruler. This will be our K. Some people can see this drawn differently. This is just how I draw it. K just usually goes straight up and down. And then you have J, which should go like that. And then you have I, which will come across like that. So those are our 3 dimensions. This is the negative direction, that's the negative I direction, this is the negative K direction, these are the positives. Okay? So, we got our vector A. It's made up of 2i, so that means we need one going, well, let's make this go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. You've got to go it goes 2 in the positive I direction, which means it goes like this. It's in the positive I direction. Then we have 3j, which means we got to go up 3, 1, 2, 3 in the positive j direction. And then we're going to go up 4 in the positive k direction. So that's 1, 2, 3, 4, all the way up here. And if we sum them, we get our A vector. So this is our 2i, this is our 3j, and this is our 4k. So we've gone 2i, up 3j, and then out at 4k. And then we get this vector that looks something like that. And that's our A vector. These 3 components make up the A vector. Okay? That's one way of looking at it. Another way you may have seen it done is, let's say R equals bracket 10, comma 45 degrees, comma 45 degrees, which is showing the magnitude. It's showing theta, and it's got the azimuth. Okay, now some people look at this in different ways, but I'm just going to do it the way I was taught. So we're going to call this the Z component, just like how we have I, J, and K. This will be X, Y, and Z. Okay, I think I need new pens, but this will be the X, Y, and the Z. And these here are the positives, and those are the negatives. Okay? So, basically, we've got 10, so we've got a magnitude of 10. Okay, so it's going to stick up at a certain point. The theta, it depends the equations you're given, really. I'll explain it a bit more when I do equations in the converting video that I have coming up, where I'll convert spherical to Cartesian and polar to Cartesian and whatnot. But the azimuth comes out here, and theta revolves coming from the Z, leaning out. So if you had, let's grab some of my pens. Let's say this was our X, Y, Z. This was X, this is Y, and this is Z. The azimuth would be coming out like that, and theta would be coming down like that, okay? And that there would be the angle where it's opening up. So the best I can draw this is, well, that's halfway, because that's 45 degrees, because that's the azimuth. Azimuth is 45 degrees, so that's about there. This will make it come out. That's about 45 degrees. And we make that meet, and that there, that diagonal that comes out 45 degrees, that would be the magnitude of 10. I know this is getting a bit messy and there's a bit of a curve there shouldn't be, but that 10 is the magnitude. So the magnitude, it's going around in the azimuth of 45 degrees, and it's coming down. It's coming out from the x-axis at 45 degrees. Okay, that's another way you can see it. And when you're finding the vector components, that's what I'll show you. I'll show you the formulas. I won't show the formulas here because it's a bit more than before. But basically, this would be the x component. And these are just necessarily components, but if you were finding it of this, that would be the x component, and this would be the y component, z component, x and y component. So yeah, I'll explain it a bit better, but that's another way you could see it. That would be the arrow there, I should say. Okay, and I'll show you another way that might make it look a bit easier and a bit cleaner. So I'll use up the whole page, and I won't do the negatives because the negatives just take up heaps of room. Okay, so now we've got this. This is our x, this is our y, and this is our z. Okay, hopefully that doesn't really fit in too much, but yeah. So let's say we have our Rx component, we have our Y component, and then we have we add them together, and that will give us this along this plane, the flat plane there, the YX plane. If we add these together, we'll get an Rx plus Ry. They should all have little squiggles or signifying that they're a vector. And then we add Rx plus Ry. We add that to our Z component, which would be R subscript Z, to say that this is the Z component of R, and that's what R would look like. So back before, when I had angles, and I said this line here was the XY component, that's what I meant. Because I said that this line here is made up. This line here is made up of the Y and the X. Okay, so you add Rx, that looks like a B, but that's an R. Adds Rx to the Ry, and that's what you get. If you've watched my vector addition video, you'd know this, hopefully. But when you add them together, they don't make a number; they just make another vector. And that's what you get there. And then when you add the Rx plus Ry vector to the Rz vector, then you get this. Okay? So if you were looking at this and you were trying to find the components, first you would have to find the Rx, then you would have to find the Ry, and then you would use those two to find that. And then once you found the X and the Y, you would use that to find the Rz component. Now, hopefully that didn't confuse you too much. I'll do a video on the just converting between them, and it'll hopefully make you understand things a bit better. Anyway, thank you for watching this video. I hope you learned something, and I hope you have a good day.